gonna do, let's just make sure, is there anyone who has not tried the practice demo test?
Me.
Keaton, you need to try it today.
Me.
I know I'm gonna work on getting Vincent a different camera to use to take pictures.
So where's that?
In the link I sent in Remind. You
Oh,
can also
that's on
Google
my
it. If
phone.
you Google it, just Google AP interactive demo exam, and it'll give you a link. So try that, and if you guys have not successfully been able to upload files or have any questions on the instructions, please just email me or send me a message in Remind, and we'll work through those specifically. Um, I think you should practice now with the method that you're planning on using. So even if that means emailing yourself files and then doing it, I would just go for the email method because you know how to do that. Just ensure that you can do it in a timely fashion. Do it on the practice test. And then Vincent was concerned also, just to remind you guys, as soon as you hit the submit button, that's what counts as your submission. It'll upload after that and keep going, and you'll still get credit for it as long as you hit the submit button while the timer hasn't expired. So, okay, we should do some problems because we don't have many more days. We've got today, we've got Friday, and then we have 2 days next week. So,
So the test is in like 2 weeks?
what one? No, test is next week. It's a week from tomorrow.
Oh God, okay.
The
Okay,
14th.
so I
Are-
really,
Are we gonna have a Zoom party after we're done?
I think we should.
You mean a cry party?
Hey, everybody always feels a little stressed out after the test, and it's normal to kind of feel like a little, what just happened, or a little discouraged even, and it's okay. That's a natural feeling. We'll celebrate the fact that we're done with it, and then we get scores. The nice thing, you won't really know your score till July. So by then you'll have kind of moved on anyways, and pass or fail, you'll be set and on to thinking about college anyways. So it's not the end of the world if you don't pass. But I would, if you're serious about passing, I would, beyond what we're doing in these sessions, I would be spending a lot of time this weekend. Traditionally we would spend, like, I think the last 2 or 3 years we've spent about a 6 to 8 hour session the Saturday before the tests, working more on problems and just last minute review. And you guys will have to do that kind of on your own. So if you really want to do this, again, looking at old practice exams, and I would just Google. We went all the way back to 2017, but you could do the 2016, 2015 tests and look at the scoring guidelines and answers. But reasonably, I know it sounds unreasonable, but I think probably 4 to 8 hours of studying this weekend would be a good thing. And maybe even the day before the test, doing an hour worth of problems the night before, or even an hour worth of problems the day of. That would probably be a good way to warm up. So I know it's a lot of chemistry, it's a lot of AP Chem, so I would just try what you can, and yeah, if you want to pass, it's going to take a lot of studying this weekend. Okay, we're going to start this question. I've got two of them. I'm doing them a little out of order. This one is a stoichiometry question, so let's go through it here. And it has some experimental data in it. It says, in the first of two experiments, a student is assigned a task of determining the number of moles of water in 1 mole of, there's our hydrate. The student collects the data shown in the following table. Says, whoa, who is that?
Oh, here, let me mute myself.
Yeah, that's okay. You can watch, Linus, you can watch another. Yep, let me hit play. Okay, so there's the empty container, there's our masses, there's the mass. These three masses are the mass of the same thing, just reheated, right? They've heated it a second time, they've heated it a third time. Question A says, explain why the student can correctly conclude that the hydrate was heated a sufficient number of times in the experiment. How do you know that their hydrate has been fully dehydrated? Somebody's got it. Sorry, you're all muted. How do you tell that that it's fully dehydrated?
When the amount of mass of H2O is gone.
Yeah, and so what's the evidence?
When it's not changing anymore.
Yep, the mass after heating is relatively constant, stops changing. And do you guys know that really on all these masses, that last digit, you know how it always fluctuates on the scale? We call that an estimated digit anyways. So you guys can see on the second and third heating, do you see how basically if you remove that estimated digit, those are the same masses? So,
yep.
So we would say that this is sufficiently dehydrated because the mass has stopped changing. Okay, part B says use the data above to calculate the total number of moles of water lost when the sample was heated. So we'll start there. So here's the final mass, right? And if I want just the mass of the water lost, I think I need to subtract off the initial mass of the sample in the container, right? So if I find the difference between those, that should tell me how much mass was lost. Are you guys okay with that?
Yep.
All right.
Yeah.
So I end up with, let me get my calculator so I don't make a mistake. 25.825 minus 23.977. So I lost 1.848 grams of water divided by 18.01 or ish grams per mole. That's the molar mass of water. You might want to have the molar mass of water, the molar mass of carbon dioxide. So let me put these up at the top. H2O, CO2. What's another one that commonly shows up? C6H12O6. That's glucose. What else would show up on the test as common? I think if you had those written down as reference, so you don't have to add them up, that would be a good thing. So divided by 18.01, I get 0.1026, and I have about 4 sig figs here, so 0.1026 moles of water. Okay. And then it says, the next one says, determine the formula of the hydrated compound. So we've just now determined that the water is 0.1026 moles, but we need to figure out how many moles of magnesium chloride. So that would be the moles of the anhydrous. So anhydrous means without water. So for that one, I would take the final mass, and I'm going to just subtract off the container. And so that'll tell me how much of the dry chemical I have left. So that would be 23.977 minus 22.347. Oops, 23.977 minus 22.347. So I get 1.63 grams of anhydrous, which would be the Mgcl2. And I'm going to divide by its molar mass, and that one I'm going to have to add up. So magnesium, 24.31 plus 2 chlorines. And sorry, I'm not writing down all my work for this. Do you guys realize for the AP chemistry test, do you think it makes sense to show any work for molar masses?
Right.
Do you need to show how you got 95.21? Do you think?
That would be a good bet.
I would say if
I don't think you have to.
No, you don't have to would be the correct answer. If you know for certain you're gonna have enough time to do the test and you want to show what you're adding up, you can. But if you have it labeled like MgCl2, they'll know that your molar mass is there. And if you happen to misadd up the molar mass, they'll probably take off 1 point, but they won't count you completely wrong as long as you've labeled it. So this comes out to 1.63 divided by 95.21 comes out to 0.0171 moles of MgCl2. All right, so I end up with this many moles of the salt and 0.1026 moles of the water. So if I want to know this formula, the last little part is determining the ratio N. N is the H2O to salt ratio. So I would just take the moles of the H2O that I have, which is 0.1026. Oops, 1026 moles H2O divided by 0.0171 moles MgCl2, and that comes out to divided by 0.0171 comes out, ooh, this one, they made it nice for us. No joke, that comes out to exactly 6. So the answer, it would be like, you'd write it as MgCl2 with 6 H2Os would be the chemical formula for that's called a hydrate again. Oh, and do you guys remember how do certain salts form hydrates, or like what is the actual structure of a salt and a hydrated salt?
Doesn't the water stick to it a bit because polarity?
Yes, and this is a weird one. So some
It's within
compounds,
like the crystal, right?
yeah, this one, okay, there's differences. Okay, attracting water and having water stick to it, that is something called hygro, Hygro, hygroscopic, and that'll draw moisture out of the air. So, like I have certain chemicals, I think it's calcium chloride, you put in, say you have a trailer. Oh, Linus is laughing. You have a trailer or you have like an RV, and it sits outside like just in the rain all winter long and you're not using it. Usually you put some of this salt, calcium chloride, like a little bundle of it inside your RV, and it keeps the moisture, the humidity down inside. So that's different. That's not a hydrate. A hydrate, the water is embedded in the crystalline structure. It's like part of the crystalline structure. So MgCl2 has a 2-to-1 ratio of chlorine to magnesium. So you've got like anions and cations that form a lattice, right? And then within that lattice, part of its structure there's 6 water molecules embedded in that crystal. So it's actually part of the crystal structure. Okay, so
So if you like had like
yeah, it's like
if you had like a tiling and like some of the tiles are replaced with like
or the mortar,
different tiles.
yes, or the mortar would kind of be like the water. Not quite, I guess, the analogy there, but yeah, some of the tiles, say you had a checkerboard effect, or every 10 tiles you had a white tile. The white tile would be representing like the water or something like that.
Okay.
Okay.
Yeah.
Yeah.
Mhm.
Okay.
No, I just lost my train of thought.
That's okay. Okay, so there's that one. It says a different student, so we're on C, a different student heats the hydrate in an uncovered crucible, and some of the solid spatters out. So they're heating this up, trying to figure out the chemical formula. This spattering will have what effect on the calculated mass of the water lost by the hydrate? So if you lose some of the solid, spattering will make the percent water, will make it look like there's more water in the compound or less water in the compound.
More.
Yep, we'll make the percent H2O look abnormally high, or higher than expected. And that's just like, because you're measuring basically steam leaving into the air. Well, if solid pops out too, and you don't account for that, then it's going to look like you've lost a lot of steam, a lot of water. Okay. In a second experiment, the student is given 2.94 grams of a mixture containing MgCl2 and potassium nitrate. To determine the percentage by mass of MgCl2 in the mixture, a student uses excess silver nitrate to precipitate the chloride ions. So he's precipitating the chloride ions as silver chloride. So it says, starting with 2.94 grams sample of mixture dissolved in water, briefly describe the steps necessary to quantitatively determine the mass of Agcl precipitate. So I know we're going to give a written sentence as an answer, but before that, I think anytime they give you chemicals and say they're going to do a reaction, you probably write the reaction first. So they're trying to figure out the weight percentage of MgCl2. Okay, it's this mixture. They want to know how much MgCl2 is in there. So they're going to add, it said silver nitrate, AgNO3. And this is aqueous, and this is aqueous. Okay, and the precipitate, they said, would be Agcl. And then what's the other product?
This is called Luna and Wolfies.
Oh, what's the other product called? Or the other?
Magnesium nitrate?
Yep, MgNO3 2. Another good thing if you're wondering what you could study, just reviewing all the polyatomic ions and their charges so you don't have to think through the charges anymore. Just doing flashcards for 30 minutes and remembering some charges would be a good thing. And that would be all nitrates are soluble. So I've got that. And then I need to balance it. Balancing it, I think I need 2 of these. So there's the chemical reaction. So they want to know if you're trying to take this mixture up top and determine the weight percentage of magnesium chloride. First, you're going to take the mixture and you're going to dissolve it in water. So step 1 would be, dissolve, mix in water. Okay. So now you've got basically KNO3 and MgCl2, which is now aqueous. Okay. And then how do you do a precipitation reaction? You're gonna take the AgNO3 aqueous and add it to the mix. Add to the mix. Okay, and so what would you observe? Had they asked the question, what would you see at this point?
Would you see less of the potassium nitrate since the potassium nitrate or the nitrate instead is being used to make the silver?
Okay, well let's look at this. So in the silver nitrate, what are the actual species participating in the reaction? In the silver and chloride, right? So what's not doing anything?
Oh, the nitrate.
The nitrate and there's one other thing that's not doing anything.
Magnesium.
Magnesium. Okay, so we can forget about the magnesium and the nitrate at this point. But what would you observe in step 2? You dump those two mixtures together. You could dump silver nitrate and that mixture. You're gonna see a precipitate, which would look like what? And I'd give bonus points for color. Does anybody remember what color this precipitate is?
Was that the blue one?
Blue one is copper. Copper phosphate.
Is this black?
No, blue's copper.
This one, silver precipitates are generally, if you remember, we did silver chloride when we did Le Chatelier's principle. We had the blue and the pink solution, and I added in some silver. Do you remember what it did to the solution?
I thought it made it black.
Not black.
Didn't it turn it like dark blue?
Okay, it turned the solution a certain color, but what color was the solid?
I just remembered.
Gray?
It was kind of whitish gray. So I know it's trivial things, but they've actually asked questions about this before. You you should know relatively silver forms white precipitates, copper forms blue precipitates, lead sometimes will form yellow precipitates. I'm trying to think. Iron, do you guys remember the color of iron stuff?
Red.
Red, yeah.
Yes, red and brown precipitates from iron. So those ones it's just kind of general knowledge. They occasionally ask questions about that. Okay, so then
What about gold?
gold will precipitate, I think, very similar to silver, and I think
Really?
it comes out kind of white.
Huh.
So, okay, number
Because they're part of the same family.
yep,
That makes sense.
number 3. Okay, so now you see the precipitate. So you see a white precipitate, white solid forms. Okay, how do you quantitatively determine the mass percent? What would you need to do next in the experiment? To collect to precipitate, what do you have to do?
Okay.
Strain the solution.
Yep, it's called filtering. We need to filter the precipitate, and you could abbreviate it if you want it, PPT. Filter the precipitate, dry.
Mm. Okay, so would washing it be part of the filtering
Yes,
process?
you could say wash and filter. Yep. And I don't think they'd get that specific, but yes, wash and filter is correct. Then you dry it, and then you would mass the final product. Okay, so that's basically how they do a lot of mining now. Instead of trying to look for big chunks of stuff, they just dig up a bunch of dirt. They put some really nasty acids in the dirt. It dissolves all of the gold or silver or whatever they're mining. Then they add in chlorides or nitrates or they add in different things that'll cause a precipitation reaction, and then they filter that. Then they take all the solids that they get and they put it in a crucible and they heat it up, and then that'll drive off all the extra stuff like the chlorides or the oxides or anything. So they don't really mine anymore looking for like what you would stereotypically think of like a gold nugget. They just dig up soil, leach it with acid, and then precipitate it and do exactly what we're talking about here. Okay, so it says the student determines the mass of the Agcl precipitate. So they do this all. They get the Agcl2. They say it would be 5.48 grams of precipitate. It says how many moles of MgCl2 are in the original mixture. So we're starting with 5.48 grams of Agcl, and there will be a stoichiometry question. So you should be prepared to do some stoichiometry. So we're going to go from grams Agcl to moles Agcl. Okay, and I'll get the molar mass in a second. And then it's asking how many moles of MgCl2. So we look back at our chemical reaction. What's the ratio of silver chloride to magnesium chloride?
1 to 2.
1 to 2. So I go in, I say 1 mole, Agcl, 2 moles of Agcl come from 1 mole of MgCl2. And I think that's what they're asking for. So I just need the molar mass of Agcl. Ag is 107.87. Chlorine is 35.45. So 143.32 grams in 1 mole. 5.48 divided by 143.32 divided by 2. How many sig figs?
Let's see. 3.
Okay, so what would that round to?
0.019.
0.019. Careful.
0 because
No.
Oh,
the
0.0191.
0.
Yep. There you go. 0.0191.
Oh, what?
Yep.
Okay.
And that would be moles of MgCl2. Okay, so that's how many moles of MgCl2 that were in the original portion. Okay, and then the last question says, what's the percent by mass of MgCl2? Remember, we started out with 2.49 gram or 2.94 grams of mixture, but now we need to figure out what percentage of MgCl2 that is. So what I'm going to do, 0.019118 moles MgCl2. I need to go from moles MgCl2 to grams MgCl2. 1 mole weighs, I think I had it up top, but I'll add it up again. 24.31 plus 2 times 34.45, 95.21. Okay, so 0.019118. Do you guys know why I started with that number instead of 0.0191?
And because you're continuing to calculate.
Very good. So you just always more precise than you need to be in your calculations. And then I round it back down to 3. So my final answer on this one would be 1.82 grams of MgCl2. Remembering that the original mixture, the mix of KNO3 slash MgCl2 was 2.94. Okay, so how do I get a weight percent now?
Divide 1.82 divided by 2.94.
There you go. So this is the grams of what I'm asked about divided by the total mass of the mixture, and that gives me and then times by 100. That gives me 1.82 divided by 2.94 times 100 gives me 61.9% MgCl2. Okay. And okay, I know that's a lot to ask, and the only reason I'm going fast is I want to do 2 questions, but it's a lot to ask of an AP chemistry student. I know you all know how to do this, and given enough time, you would all get it. It's hard to think on the fly, so here's what you got to do. You gotta know that it's stoichiometry. You gotta know the general setup where we're doing some chemical reaction, then we're doing some unit conversion, and then we're coming up with some experimental result. You got to know the general flow, and even if you don't know how to do it, if you set it up and show that stuff, you will be graded well. If you just write random gibberish on the page with no concept of like, oh geez, I don't know what stoichiometry is, so I'm just going to put some random numbers down, or even if you do know, yep, you can watch one more. Even if you do know, but you don't formulate your work in a coherent fashion, they're gonna mark you down.
Okay. I need to go.
Okay. So Arthur,
Okay.
you've done the practice test?
Yes, I have.
Okay, so we'll see you Friday. We got a couple more sessions. Have a good day.
Okay.
Okay.
Everyone vote for Evan for prom king. Okay. Goodbye.
Okay. I'm gonna go back. This next question was an awkward question, and so that's why I'm saving it for second. But there's some weird stuff in here that's kind of obscure, but they gave it as a practice question, so I figure we better talk about it. So this one will be like the short question. It will only take, this one will go fairly fast. So we'll say another 10 minutes or so. Consider the 2 chemical species S and S2 minus, so that's sulfur and sulfide. Write the electron configuration of each species. So sulfur, if you look on your periodic table, is element number 16. So what's the electron configuration for that?
Can we use abbreviation?
Yes.
That'll be any
for S2.
Yeah.
Any.
And then
3p4.
Yeah.
3s2, 3p. What was it?
4.
4. Correct.
Yeah.
Correct. Okay. And then sulfide. So that's sulfur. Sulfide S2 minus would be neon. 3s2, 3p. You guys okay? So 3p. What would it be?
Well, if it's 2 minus, doesn't that mean it has 2 more electrons?
Yeah, it has 2 more.
So can you just say it's argon?
Yes. Hey, so either way, you'd show it like that. Either 3s2, 3p6, or you'd call it argon.
Okay.
Okay.
I like to use abbreviations.
Yeah. Now, hey, Keaton. They for certain said that this was an acceptable answer for sulfur. For sulfide, I think it is important, and you'll see in the questions below they're going to ask about the electrons on the outer shell. So you might, I don't know. I think this is a more appropriate answer just based on the questions that are coming up.
Yeah. Yeah.
So, okay. Part 2. Explain why the radius. So why is this one larger radius than sulfur?
Because it has more electrons
More electrons, specifically where?
on the outside.
shell.
More.
They want to repel each other more on the outer, because they're more on the outer shell.
More electrons in valence shell leads to valence leads to more repulsion. Leads to more repulsion, which makes it larger, making it bigger. Throw in as many like keywords. The keywords there would be valence and repulsion. Okay, part 3. Which of the two species would be attracted to a magnetic field? Which one would be attracted to a magnet? Can you take a guess?
Would it be the one that's more?
Sulfide.
Yeah. Wait, why would it be sulfide? I think it would be sulfur, right?
All right, the correct answer. This one, and we did a little lab on this, and I'll jog your memory. The correct answer is sulfur, just the S, and it has something to do with arrows. Can you guys, with that little hint, why would this one be? It's called paramagnetic.
Oh, I remember that. I was just thinking about how, like, let's say a magnet, like, I don't know, with electrons.
Here's the review. This one
Does it turn all the spins up?
It has to do with spins. So what would a 3s2 3p4 look like? I'm just drawing the valence shell. Do you guys remember these?
Yeah, it'd be one up,
Three
down.
would be down, one would be up.
Oops, up, down. Okay, and then up, down, and then how about in the P?
Up, and then go back and then down.
You guys, okay? So why is that attracted to a magnet?
Oh, is it because?
It's because of these guys. What would you call those? They're called unpaired electrons.
Yes. And is that why a magnet is like, ooh, gimme?
Yeah, that's why we have this word for it. Paramagnetic means attracted to magnet.
Cool.
Okay, and then diamagnetic, because the other one, sulfide is diamagnetic. Diamagnetic things actually are slightly repelled. So if you guys remember, when you put your hand really close to a magnet, do you remember how it pushed down on the scale?
Yep.
That's because the water in your body is diamagnetic. It has completely paired electrons, no unpaired electrons in your body. And so that's why it caused the scale to get pushed down and repelled. Versus like yeah, go ahead.
If sulfur was S1 plus and it only had 3p3, would it be paramagnetic still?
Yes. As long as it has at least one unpaired electron in those boxes, then it's going to be attracted to a field. It's going to be paramagnetic.
Okay.
Yep. If it has completely paired where everything has an up down, then it's diamagnetic. Okay. And I don't even think AP cares about the words paramagnetic and diamagnetic. They just want you to be able to identify the unpaired electrons. They want you to be able to draw these diagram boxes and see if something is paired or unpaired. Okay.
That is very strange that sulfur is magnetic.
Well, it's not magnetic itself. It's attracted to magnetic fields. So if you have a
That's
magnet,
weird.
if you have a magnet next to it, what it does is it induces an attraction. Okay, versus sulfide, if you put a magnet next to sulfide, it'll actually induce a repulsive force.
What I'm saying is like a piece of like metal, like if you have just iron, right?
Yeah.
It's going to be attracted to the magnet. Is what I'm saying is very strange about sulfur.
Correct. That's correct. But however, like it's not going to sulfur itself won't attract a piece of metal.
Yeah,
Yeah.
yeah. I'm not saying that it itself is a magnet.
Yeah. Okay.
How
Good.
are magnets formed? That's another
Good
story.
question. There's some rare earth. That's beyond the scope of me. I know that a lot of them,
No idea.
no, especially neodymium magnets, have some rare earth elements in them. But I do know magnets are generally formed when atoms are aligned. So you can turn a piece of iron like a nail magnetic by taking a magnet, and all you do is rub a magnet across it, and if you rub a magnet across it in one direction, that'll turn the nail magnetic because you've aligned certain things within the atomic structure. So anyways, okay, moving on because we got to finish. Okay, it says that the S2 minus ion is isoelectronic. We've already shown it's the same electron structure as argon. From which species S2 minus or argon is it easier to remove an electron? So remember, S2 minus is again neon, 3s2, 3p6. Okay, and argon is also neon, 3s2, 3p6. So which one, if you're removing an electron, like you're removing it from here and here, which one's going to be easier? Which one is it asking, easier or harder? Easier to remove.
SP3?
No. Which one of these? S2 minus?
No. I'm saying that you have 3s3. I'm very confused why.
Oh.
Okay. I would say
which one is it easier to steal these electrons from?
The S2 minus.
Why? That's correct.
Because the argon's already happy.
Nope, that's not the reason.
Oh.
What's holding these electrons in place?
Oh yeah, wait, they're the same. Okay. I have no idea.
Sulfur has less attraction from the nucleus.
Yes, correct. This one has how many? Sulfur has how many protons?
Oh yeah. However many?
Yeah, look it up.
It is 16.
16.
Very good.
Yeah.
This has 16 protons. How many does argon have?
It has
18.
18. Yeah.
protons.
Okay, that makes sense.
So hey, this one has less pull from the nucleus. Okay. So again, when they say isoelectronic, you know the answer can't be anything to do with electrons. It has to be something else. So the protons in sulfur, since you have two less, it's going to be easier to remove an electron because there's less attraction. Okay. Next thing. This is the obscure question that I was a little worried about why they're even putting it on here. I actually looked this up. This came from a test in 2009. So this is probably not likely that they would ask this, but let's work through it anyways. In the H2S molecule, it says that HSH bond angle is close to 90 degrees. On the basis of this information, which atomic orbitals of the S atom are involved in bonding with H atoms? So here's the weird thing. If you draw H2S Lewis structure, you add it up, 1 plus 1 plus 6 valence electrons comes out to 8. And you draw S and an H and an H. I don't know why I put that one so far away. Drawing too fast. And you draw in your 8 electrons, right? And you could draw it like maybe that it's 90, but you're thinking, wait, this is weird. When we draw something like water, this is what I was thinking right away. Oh, water. Okay, that looks like what kind of geometry to me?
Bent.
It looks like sp3, and it looks bent, and it looks like 109.5, and I'm thinking, well, hey, doesn't H2S, because sulfur and oxygen, these are like in the same group. Oops. Why isn't sulfur 109.5? Why is this 90? And I'm thinking, okay, these are big, but so are these. So why are those two angles not closer to each other? And I would be super, again, this is like a stretch, but I would be really impressed. The orbitals in water are sp3 hybrid or hybridized orbitals. What orbitals do you think are involved in these bonds?
Is it um the
Is
s
it?
orbitals?
Hey, good guess. It's actually the p orbitals. And this one, I don't think they'd ask this, but just to
Really?
review, the p orbitals, okay, if you guys, when we started talking quantum way back in general chemistry, or maybe at the beginning of this year, s orbitals look like spheres. Like the 1s kind of looks like a small sphere, the 2s, oops, 2s looks kind of like that. The 3s looks actually, and these ones are weird. They actually have like these nodes in them, but they get bigger, right? The p orbitals. Do you remember the shape of the p orbitals?
Oh, aren't they lobes?
They're lobes, and they come in. Oops, they come in three forms. This might be the like 2px and the 2py, and I gotta draw it. This should be three-dimensional. The 2pz.
That makes sense.
Yeah, and so what they're saying is maybe this lobe right here is like the 2px, and this lobe right here is the 2py. And you guys see x and y axis, how many degrees are those offset by?
90.
90. So that's the weird one. I would, again, this is obscure. You should kind of remember that p orbitals, they're lobe shaped and they're offset by 90 degrees. And then just for reference, d, they're too complex to draw and they're beyond the scope of AP chemistry. They look,
Of human knowledge.
well, they're, and you guys remember what elements have d orbitals?
The ones we don't talk about.
No, those are the f orbitals.
Oh, yeah. Okay, DL orbitals, aren't those the transition metals?
Correct. And so that's why transition metals like copper and iron will form very colorful things because of their orbitals when they bond to different things, and when they interact with water molecules in solution, the complexity of their orbitals will absorb different wavelengths of light. So when you get these weird orbitals influencing the chemistry, you'll get very colorful solutions. So the d orbitals are fairly big, like complex, and the f orbitals are even beyond that. And yeah. So, anyways, this would be a weird one. The correct answer to this question is H2S likes to bond with its p orbitals. It doesn't use hybridized orbitals. So it's like an exception to the hybridization rules. Usually we would say things like that are hybridized, but this one likes to use its p orbitals. Okay, so last part. Two types of intermolecular forces are present. So I'm on D. It says London dispersion forces and dipole-dipole forces. Part I, compare the strength of the London dispersion forces in H2S to the London dispersion forces in H2O. So here you go. H2O versus H2S. And you've got electrons, see if you guys can tell, electrons that kind of look like this, and electrons that kind of look like, I'll draw it a little bigger, like this. Okay, which one is going to have stronger dispersion forces?
From what?
Silver. Silver has more electrons.
It has more electrons, yep. It's got more electrons, so it's the word, it's more polarizable, meaning they can shift to one lopsided, make it lopsided more than water can. So this one would have stronger London dispersion forces because it has more electrons. Okay. Now, this is the weird part. Would the London dispersion forces be the dominant force in either of these molecules?
No.
No,
No, they have dipole-dipole.
correct. Dipole-dipole or even H bonds because these are both polar. So, but for this question, you would say they're both London dispersion forces. The ones in H2S are more polarizable, so stronger. Okay, and then the last question is compare the strength of the dipole-dipole forces in these. So dipole-dipole, right, comes from the fact that these are lopsided. So you've got like and I drew the arrows like relatively the same size, but that's wrong. Which one would have a stronger dipole and why? Which one would have a stronger dipole and why?
Oh, would it be the H2O?
Correct. Correct. This one has stronger dipole. Oops. And why?
Is it because the H2S is like how we explained before, it bonds with its P, so it's like less lopsided?
Oh, hey, that might be one reason, but that's not the most straightforward reason. So it has to do with electronegativity. So what can you tell me about the electronegativity of oxygen?
Oh, it's higher than sulfur.
Correct. It's very high. So what's going to happen is all these electrons are really going to get pulled towards the oxygen, okay? Like really strong. Versus in sulfur, these electrons are just barely going to get pulled towards sulfur because it's not as electronegative. Because it's not getting pulled as much, this dipole is weak. This dipole is strong. So this one has stronger dipole-dipole forces because oxygen is very electronegative, or it's more electronegative than sulfur. Okay. Does that seem like a reason? And Keaton, you're probably right. It may have something to do with angles as well, but I think this one's more dominant.
That makes sense. Yeah, probably.
Okay, so and you could even say it's so strong electronegative that this one is capable, oops, this would be another way to say it, capable of H bonds, right? And sulfur isn't one of those three special cases, so it's not capable of H bonds.
Ooh.
Okay. So, okay, we've gone 50 minutes, so I'm going to stop. If you guys have, at this point, specific questions, you can either all hang on for a few minutes, you can get some feedback, or you can just email me or remind app. And hey, Vincent, are you still on here? Let's see.
Yeah.
Okay, hey, Vincent, so I'm going to figure out now, is there nobody in your family or friends who could deliver a camera? Because I could ask the school district for one. Is there an easy way for you to get a digital camera between now and the test? Or like the day before the test so you can practice with it?
Well, the thing is that it seems like if I have some external camera, how am I going to get it to my computer fast enough within 5 minutes?
Like, do you have like a card reader or a USB cable? Like if I got you a camera and a way to get it in your computer, like that would be the easiest way, right? Just download it straight from the camera.
Probably.
Okay, so I will now. Do you have anyone who like has a couple-year-old digital camera, or would you like me to try?
Yeah, I think.
Try and get you one.
I think we might.
Look into it. Could you let me know by like tomorrow if you'd like me to scrounge? I'm basically gonna email the tech department and see if they have some kind of a digital camera that we could use. And then I'll either get you a cable or a USB card reader, and you'll just basically download the image straight from the phone onto your computer, then attach it.
Okay.
So let me know by tomorrow. You can just email me.
Okay.
Okay.
I have a question. So it's about college. I'm taking my math placement test, Mr. Ford,
Yeah.
and I was wondering exactly what type of class needs to be taken before you go into differential calculus?
Yeah.
Because I know that it says prerequisites, but I need to know, like, because I've taken pre-cal,
Yeah.
I took 3/4 of it. And I need to know if calculus is the next level, like
Yeah,
differential calculus that
yeah.
I need to take.
Yeah,
Is it?
calculus is the next level. Like basically, if you do you feel comfortable with like because you're going to be doing a lot of exponential functions, logarithmic
Yeah.
functions, and then do you feel good with trigonometric functions and trig identities?
Pretty comfortable with trig identities. I took the Alex test. I already took the practice test where I practice it and it teaches me stuff. So I got a 65% on it.
Okay.
First time I did it, and so I just need because it's out of 30, I just needed like 3 more questions, which I don't know on 3 of the questions. So
Okay, hey, so here's what I would recommend this is just based on where we're at with the whole COVID thing. I would look into taking, because you've had like Patterson is still, well, you haven't been doing any pre-cal since basically you graduated, like the 13th, right?
So what Alex does is after I take the practice placement test, it gives me a path that it puts together a bunch of practice questions in this timeline. It gives me 1 page of just, this is how you do this. This is the answer to this practice question, and then it makes me practice it 2 or 3 times.
Yeah.
And then it goes to the next topic, and then I just keep doing that.
I would look into in addition to that, because that's not bad, but just to get the hang of online class, I would. No, Linus, we're gonna stop right now and eat some lunch. You should look into like a PCC class. You should even. Have you ever had Mr. Groom as a teacher?
No.
Oh, okay. Mr. Groom teaches some online courses at PCC and at PSU and at OIT.
Okay.
It might not be a bad idea to take like one of those, like I think they're like going to be like a 190 math 160 or math 190. It's basically pre-calculus.
Okay.
It might not be bad and it won't be that expensive. Just a second, Linus. Let me finish this. You could look into, and I really think that would be a good idea, because you're probably going to have some form of online class because of COVID, like when you start the fall.
Yeah.
So
that's not if in the next few months Oregon opens up, which I'm hoping.
But still, I bet, I'm pretty sure, certain, even if classes are open, it won't be fully open. You're gonna do part of it. You'll do part of it online, and you'll do part.
Yeah.
So I would say register for a PCC class, like, and especially if it's Mr. Groom, and try the online stuff, and just get back in the swing of math. And that would be a really good way. I think it's gonna, it'd probably be like $150. I know that's a lot, but like, make it work. Make it work. That will help you. That will go the longest way.
That's true.
Than just a practice test. Like you'll be more likely to pass and not have to retake differential calculus, because the calculus is a class that a lot of people have to try multiple times.
Mm-hmm.
And so
I have to take it twice.
Well, you have to take differential, integral, and you have to take differential equations, which is different. So you have to take 3 calculus classes, right?
That's fun. Oh yeah, I'm taking the same degree as you. Yeah. I forgot. You know exactly what I'm doing.
Yeah, you got just a bunch of calculus, and so the likelihood that you make it through without having to retake any of those is pretty high. You will probably have to retake at least one of those. And like even my friends who are engineers, and like they in differential equations, I think that was where I got a B, my first B. Then some of them, they worked really hard, they got a C or a D. They ended up retaking it just to help their GPA, and so they took it twice. So it's pretty likely you'll have to retake class. It'll be less likely if you start now and do an online class this summer.
Okay.
So I'd look.
And do you know when summer classes start? Because I have to take my Alex test in the next 10 days.
Yeah. Well, take that. I would say focus on your. I would say your.
Yeah, because the practice.
Yeah, I don't know. You could study for both and take them, but summer classes start in June.
I'm gonna get the 75 in the next 2 days. I was super close on my practice test. I just need to study a little bit more. I'm probably gonna take it tomorrow.
Okay.
I'm gonna wake up early. I'm gonna have my mom wake me up at 9 o'clock.
Okay.
Either that or set an alarm, whichever works.
Okay.
Then I'm gonna take my test after eating breakfast and stuff. And there you go.
Okay.
Anyways, you have a great day.
Yeah, you too.
Have good lunch.
All right.
I'll see ya. Thank
See
you.
you later. Bye.